Scientists reveal what a nuclear explosion would do to an asteroid. While it's been a favorite disaster movie theme, nuking an incoming asteroid in the real world has been touted as a very bad idea. While a nuclear bomb could possibly obliterate a smaller asteroid, nuking a larger asteroid would only break it into pieces. Those pieces would still threaten our planet and perhaps even make things worse by producing multiple impacts across the planet. But is using nuclear weapons on an incoming asteroid really a bad idea? And if the right technique is used, a nuclear blast could possibly be used as an asteroid deflection device to protect our Earth. Researchers at Lawrence Livermore National Laboratory, LLNL, have now created a modeling tool that can simulate what might happen if a nuclear device is detonated above the surface of an asteroid. The tool is helping to improve the understanding of how the radiation from a nuclear blast interacts with an asteroid surface, and also looks at the shockwave dynamics that might affect the inner asteroid. The explosive technique called nuclear ablation, where the blast radiation would vaporize part of the asteroid surface, generating an explosion, an explosive thrust, and a change in velocity in response. The model can incorporate a wide range of initial conditions which simulate the kinds of asteroids we've recently been able to study up close, from solid rocks to rubble piles. These simulations are giving planetary scientists more insight and more options for when a space rock might one day be bearing down towards our Earth. If we have enough warning time, we could potentially launch a nuclear device, sending it millions of miles away to an asteroid that is heading towards our Earth, said researcher Mary Berkey from LLNL. We would have detonated the device and either deflect the asteroid, keeping it intact by providing a controlled push away from Earth, or we could just disrupt the asteroid, breaking it into small, fast-moving fragments that would also miss the planet. Thanks to the Double Asteroid Redirect Test DART mission, where a kinetic impactor was deliberately crashed into an asteroid to alter its trajectory, scientists have learned much about what it would take to redirect a dangerous asteroid. This new asteroid, this new model called the X-ray Energy Deposition Model, gives researchers the tools to build upon the insights gained from DART while exploring how nuclear ablation could be a viable alternative to kinetic impact missions. Berkey said to LLNL Press that nuclear devices have the highest ratio of energy density per unit of mass of any human technology, which could make them an invaluable tool in mitigating asteroid threats. But as the team wrote in their paper, published in planetary science journals, predicting the effectiveness of a potential nuclear deflection or disruption mission depends on accurate multi-physics simulations of the device's X-ray energy deposition into the asteroid and the resulting material ablation. The team said the relevant physics in these simulations require a variety of different complex physical packages, and they span many orders of magnitude and are computationally very demanding. Berkey and her colleagues set the goal of developing an efficient and accurate way of modeling nuclear deflection for a range of physical properties of an asteroid. She said that her high-fidelity simulations can track photons penetrating surfaces of asteroid-like materials, such as rock, iron, and ice, while accounting for many more complex processes, such as re-radiation. The model also considers a wide variety of asteroid bodies. They said this comprehensive approach makes the model applicable to a wide range of potential asteroid scenarios. If a real planetary defense emergency should arise, Megan Bruck-Seil, LLNL Planetary Defense Project Lead, said this high-fidelity simulation modeling will be critical in providing decision makers with actionable, risk-informed information that could prevent asteroid impact, protect essential infrastructure, and save lives. And while the probability of a large asteroid impacting during our lifetime is low. The potential consequences could be devastating, Brooke Seale said. And this is on Universe Today by Nancy Atkinson on Science Alert. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.